Hello, everyone, and welcome to Calculus. Today we are doing the integration of exponential and logarithmic functions. And I have to be perfectly honest with you, the only reason that you would watch this video is to get the answers and to get help on maybe a couple that you can't figure out. But now that you can see this formula, you should see if you can apply it all by yourself. Of course, I am going to do them all out, but honestly, this is a great section for just seeing if you can use the formula and apply it. So on number 1, remember that 2 is a constant. So whenever you have a constant, you can take it out. And also remember that it doesn't matter if du is written on top or if it's written out in front. So if you want to have it written both ways in your appendix or in your mind, that would be good. I'm always trying to get everybody to understand this concept that 1/3 x is the same as x over 3. Really important. So now you can see that this exactly models what we have. Therefore, the 2 stays the same, and the integral of 1 over x dx is the natural log of the absolute value of x. It's absolute value because you can't take the log of a negative number. Remember that a logarithmic graph looks like that. There is no log of a negative number because it's the inverse of exponentials, and exponentials don't produce negative numbers. Now, the only way you can do one of these is if you have this format, this exact 1 over x or 1 over u du. So if you have something else, you're going to have to call it u. 1 over, or u is equal to x plus 2, and du is equal to 1 dx. So this is perfect. I have 1 dx, so I'm going to change that to my du, and I have x plus 2 is my u. I have the exact thing that I need. So this is equal to the natural log of the absolute value of u. And now you can fill the u back in. So of course the question is, well, if you hadn't bothered with the u, you would have gotten the same answer anyway, only because the derivative of u is equal to the derivative of x. If there's anything else there, if there had been a 3 there, let's say, and then the 3 here, then you would have had to do something. So if you ever find a case where u creates a du that's equal to just 1 dx, then you don't actually have to use u substitution. On this next one, so like before, I see 2 trig derivatives, or 2 trig functions. So one of them is going to be my u, and one of them is going to be my du. And hopefully you've done enough of these now that you can look at it and say, oh, u is equal to tangent of 2x. I see the derivative is right there. So I get secant squared of 2x times the derivative of the inside, be careful with that, dx. But if you do this, you're going to end up with the du. Actually, I don't have the 2, so I'm going to have to add the 2 and the 1/2, just like we've done in other sections. But you're going to get 1 plus u. Is 1 plus u what you need? No, you need u. But this is easily fixed, more easily than people think it is, because you can make your u 1 plus tangent of 2x and actually still have the exact same derivative, because the derivative of 1 is 0. So it still works out. But now I have du over u, which is what I need. The 1/2 is a constant, so I'm going to keep it. And whenever you have this format, it always turns into natural log of the absolute value of u, which is equal to 1/2 the natural log of 1 plus tangent of 2x. That 1 and that absolute value look the same, but there they are, plus c. Okay, let's do another one. So obviously these are a little designed. You might otherwise have to think about this one, but since we're in the natural log section, of course, that's what's on your brain. But these are a little harder for people to see in the middle of a test when you're not just focused on natural log. This gives me -3 dx. I don't have a -3 dx. I have a +3 dx, so I'm going to add a negative to my problem. And then I'm going to write it as negative integral. This negative 3 and this dx become my du. And put the whole thing on top over u. I have the format that I need. So this is equal to negative natural log of the absolute value of u. And now I can put my u back in, 2 minus 3x plus c. So this is actually how we integrate tangent. Remember, sometimes people accidentally write secant squared. If y is equal to tangent, its derivative is equal to secant squared. But there's no derivative that's just tangent. There's a secant tangent. So then the question is, how do you go backwards? You do it by changing it to sine over cosine. Now you have two trig derivatives. One of them is going to be your u, and if you made the u the top one and the du would be the cosine of x, you would end up with the integral of u over du, and you can never have that. Never have the du in the denominator. There isn't a single problem we will learn all year ever that will have the du in the denominator. So this would be wrong. So instead, we're going to do u is equal to cosine of x, and du is equal to negative sine of x dx. Got my dx here. I don't have negative sine of x dx. I have positive, so I can add a negative to it, but then I also have to add a negative to the outside. That gives me negative integral of du over u. And now I have the right format, and I can change this to negative ln of the absolute value of u, which is negative ln the absolute value of cosine. A lot of people really understand this when I'm teaching it, and this is a commonly missed one on the test. They just don't think of it. They don't think of how they can do tangent. Natural logs is not going to be the first thing that comes to your mind. So number 6 just lets you practice the exact same thing with a harder problem, because I wanted to point out that when you change this, the sine and the cosine will still both have this angle. No matter what you do to a trig function, the angle never changes. Cosine of 6x squared minus 5. And remember from last time that when you have two trig functions and one of them is going to be your u, in this case we've already learned from number 5 that it's going to be the bottom one, that it's okay to have something other than just x here. So u is not going to be 6x squared minus 5. When you have two trig functions, one of the entire trig functions is your u. Du is negative sine of 6x squared minus 5 times the derivative of the angle, which is going to be 12x to the first. All right, I don't have a 12x, I have a 4x. So if you're very clever, you might see that you can multiply by 3 and 1/3, and that will give you a 12x. If you get that, that's great. But just in case you don't, I'm going to keep this with the same method that we've always used, which is give it a 12 and give it a 1/12. And it'll work out exactly the same. Because I bring out the 4, which is a constant, the 1/12 is out there, the x and the 12 dx, oh, actually, I guess I need to write it down at this line, dx and 12 and 1/12, because the other one doesn't have the sine and the cosine in it yet. So my x, my sine of x, and my 12 dx are all that. Oh, missing a negative. So in addition to that, I also need a negative on the inside and the outside. So I have a negative there. And now the 4 I took out, the x, the sine, the dx, and the 12 all make my du. And on the bottom, I just have u. So it's a matter of taking all the pieces and making sure every single piece is accounted for over here. The negative couldn't get rid of, the 1/12 couldn't get rid of, the 4 I couldn't get rid of, but the x and the sine of 6x squared minus 5 and the 12 and the dx are all right here. That's the replacement that equals du. That gives me negative 1/3 natural log of the absolute value of u, which is negative 1/3 natural log of the absolute value of cosine of 6x squared minus 5 plus c. Because the last two are almost identical, I'm going to write the answers over on the side and see if you can get them on your own. But of course, I am going to do them out. Sine of 5x plus c. All right, so the first step on the cotangent one is like tangent. We're going to have to change it to cosine of x over sine of x. My u now is going to be, whenever you have two trig functions, one of the two is your u. So I'm going to make it sine of x, tempting to make it cosine because that's on top. But I need my du to end up on top. So du is cosine of x dx. That makes it all very straightforward. The cosine of x dx is now my du, and the sine of x is now my u. This fits the pattern that I'm looking for, so I can write my answer. My final step is to put the u back in. U was sine of x, and I'm done. All right, last one on this page. Again, I was just trying to make it a little bit more complicated. So the cosine of 5x over sine of 5x. My u is still sine of 5x, but now times 5, the derivative of the angle. Oh, not yet. Sorry. My u is sine of 5x. My du is going to be, I'm so excited to remember the derivative of the inside. The derivative of the inside times 5. Do I have an extra 5 in there? I do not. But I'm going to add the 5 and the 1/5. So now I can rewrite this. The 1/5 is a constant and it stays. But this entire piece, the 5, the cosine of 5x, and the dx, all become du over u. I have the format that I'm looking for. So I can change this to natural log of the absolute value of u. And my final answer is the natural log of sine of 5x plus c. Great. Let's go on to the next page. This says the integral of exponential functions. So most of them are just going to be e to the u. You might remember that the derivative of e to the u is e to the u du. So as long as you have the du, you can go ahead and integrate. Remember, as before, if it's not e, if it's anything else, you have to use this formula. Again, I would love to see you just do them, so I am going to take just a minute and write up the answers. That's not plus up there. Plus c, this one is 3e to the x over 3 plus c, e plus c, 5 to the x over natural log of 5 plus c, 14 natural log of 1 plus e to the x plus c, natural log of x plus c, and 2e to the square root of x plus c. But I will do them out. Okay, first one. So the only thing that you can integrate is e to the u. That's it, e to the u. So it's going to be very easy to figure out what u is. U must be x squared, which would make du 2x dx. I have the x and the dx, but not the 2. So I add a 2 to my problem and a 1/2. The 1/2 stays, the integral stays, the x, the dx, and the 2 make my dx, and now I have e to the u. Now, believe it or not, these are actually hard for kids because they feel like they didn't integrate on this next step. But the integral of e to the u, as long as this is, sorry, I accidentally wrote dx. As long as this is e to the u and you actually have du, the answer is just e to the u. And that's a little tricky because you feel like you didn't do anything, but you did. 1/2 e to the, and remember u is x squared, plus c. Now, you can check this super easy. 1/2 e to the x squared plus c. If you took the derivative of e to the anything is e to that same thing times the derivative of that thing, 2x. And the derivative of c is just 0. Those cancel, and sure enough, what do you get? E to the x squared times x, which is exactly what we have. So they're very easy to check. The only thing you can take the integral of is e to the u du. So you have to make u x over 3. That would make du 1/3 dx. I don't have a 1/3, so I put a 1/3 in and a 3. So the 1/3 dx becomes my du. E to the u, the integral stays, and the 3 stays. And like I said, sometimes this is hard for kids. You feel like you haven't done anything, but the integral of e to the u du is just e to the u. And that leaves me with 3e to the x over 3. What's great is you can take the derivative to check. Now on this next one, you might think at first that this is harkening back to natural logs, and you could make u equal to e to the x. And then you would have the whole 1 over u, and it goes back to the last section. We are going to have one of those in a minute. But in this case, you can't because your du would also be e to the x, and you don't have an e to the x on the top. So if you're ever going to make your u e to the x, you better have 2 e to the x's in the problem. So it's not going to be that. So you're going to do this one the way you would anything that was in the denominator. You're going to move it to the numerator. And now your u is going to be negative x, and your du is going to be negative dx. I don't have a negative dx, so I add the negative, and I add the negative. Now I have e to the u, and all of this is my du. Now I have the format that I'm looking for, and as much as it feels like you're not doing anything, the integral of e to the u is e to the u. Make sure you put your x's back in. And of course, you could write this as negative 1 over e to the x plus c. Always be familiar with different answers because your worksheets, will have different ways of writing it, and you can't be bogged down by the fact that you can't understand it. So on the next one, you want to use the formula that's at the top of your paper. So this is really a to the x. So it says at the top that the integral of a to the x dx, it actually gives it as a u. So I guess I'll stick with the u. But in this case, why did it not really matter? Because if it's just x, you don't really need the whole u thing, is equal to a to the u over this little extra step like we had with derivatives over the natural log of a. So you just have to be able to follow the formula. So the integral of 5 to the x dx is going to be, you repeat this thing, 5 to the x over the natural log of a, so in this case the natural log of 5 plus c. It's literally, can you follow a formula? When kids miss this on the test, I get so mad because if you just have this formula in your appendix, you can't go wrong, right? And if you're in AP and you don't get an appendix, you just have to memorize it. So I'm sorry there's so much memorization, but I don't make the rules. Okay, so remember, we have 2 e to the x's. When you have 2 e to the x's, That's just like trig derivatives, one is going to be your u and one is going to be your du. Well, since you don't want your du on the bottom, your u is going to be 1 plus e to the x. And your du is going to be e to the x, because the derivative of 1 is 0, and the derivative of e to the x is e to the x dx. So I have that, because this dx could just as easily be on top. It means the same thing. So now I have the integral of du over u. A lot of people don't see this on their own, though. It's always easy when I'm doing it for you, which is why I said you really should try to work ahead and see if you can figure these out. So this gives me the integral. Sorry, I'm going to do the integral. So this is going to give me the natural log of the absolute value of u, which is the natural log of 1 plus e to the x plus c. Okay, so now we have two different things going on. We have an x and we have a natural log of x. In your head, you need to be thinking, I don't have a product rule. It's integration. The only way integration works is if one thing is u and the other one is du. So try it both ways. If u is x, then du is just dx. That's not going to help you. That's not going to get rid of that natural log. You'll have du over u, and you'll still have a natural log of x. So try it the other way. When you have two different functions, one of them has to be u and one of them has to be du. So make this function the u, and sure enough, what's the derivative of natural log? 1 over x dx, or dx over x, which is exactly what you have. I'm not trying to make it sound easy. I know it's hard. You're not going to see it at first. How do you end up seeing these? Practice. I'm in the correct format for a natural log answer. This one's especially confusing because it's kind of like, oh, didn't I already do natural log? But now the integral of du over u is the natural log of the absolute value of u. And then you put u back in. It's the natural log of x, which is not intuitive. So you gotta trust your steps and do each step. All right, so again, I see a couple different functions going on. I see a square root, I see an e. Now I know right away that u is not going to be e to the square root of x. I know that because the only way I can have u be an e is if there's another e in the problem, because the derivative of e has another e in it, and there's only one e. So I know that this isn't the way I'm going to do it. My second way of doing it is to say to myself, well, I could just go with e to the u du. Yeah, that's definitely what you want to do. This is what we did way back in the beginning. This one's just harder, and we did a couple different problems in the middle, which distracted you from remembering the main thing for e to the u is e to the u du. So u is equal to the square root of x, which of course I'm going to rewrite as x to the 1/2. My derivative is 1/2 x to the 1/2 minus 1, which is negative 1/2, which might be easier to write as 1 over the 2's on the bottom and the square root of x is on the bottom, dx. So I almost have that. I have dx over the square root of x. I don't have that 2 on the bottom. So I'm going to put a 2 on the bottom and a 2 on the top. So the 2 on the top stays. I only added that to get that 2 on the bottom. The integral stays. I now have e to the u, and all of this is my du. Now I have a nice easy format. I'm going to feel like I'm not doing anything, but the integral of e to the u, if I have du, is just e to the u. And this becomes 2e to the square root of x plus c. That's it. It is a nice short lesson today, but these problems you're definitely going to want to do them on your own and make sure that you understand them. So there's a worksheet that you can use to practice. Have a great day.